So we're going to keep it, relatively casual. I have a list of questions here. I'm going to be switching from English and French, so un peu à la Trudeau. So I hope you'll indulge me. And then I'll invite both of you to go ahead and answer the questions. À la fin, on aura un petit moment pour prendre les questions du public aussi. Donc, on a bien sûr beaucoup parlé déjà aujourd'hui de ce don transformationnel de nos instituts ici. Et sur la scène internationale, bien sûr, tout le monde connaît la NASA. Mais, peut-être que vous le savez, nous aussi, on a une agence spatiale au Canada qui est très proche d'ici, en fait, juste sur la rive sud, sur Saint-Hubert, à Saint-Hubert. Donc, le Canada est très important sur la scène internationale, mais pas tout le monde est au courant. Donc, je demanderai à mes invités, d'après vous, c'est quoi le statut de Montréal, du Québec, du Canada dans le monde de l'astrophysique et comment les dons d'aujourd'hui vont aider à l'évolution de notre statut sur la scène globale?
Écoute, je dirais que... vous m'entendez bien? Oui? Le Canada, en fait, le Québec se débrouille très, très bien en astrophysique. Il faut dire que l'astronomie au Québec est relativement jeune. Elle a pris son essor avec l'Observatoire du Mont Mégantic dans le début des années 80. En fait, McGill est arrivé un peu sur le tard avec Vicky au début des années 2000. Et c'est un groupe de recherche qui a cru littéralement comme un champignon. En moins d'une décennie, McGill est devenu un groupe de recherche aussi important que n'importe quel groupe ailleurs au Canada, Montréal, Toronto, UBC. Mais de façon plus générale, le Canada, qui a accès à des infrastructures scientifiques d'importance, on parle du télescope Canada-France-Hawaii, les télescopes Gemini, maintenant James Webb, on se débrouille très, très bien. Les indicateurs d'impact montrent que le Canada est vraiment sur le podium de l'excellence en astrophysique. Et au Québec, maintenant, aujourd'hui, je pense qu'on peut dire qu'il y a un brillant avenir pour l'astrophysique au Québec. Là.
Vicky?
Quand je suis venue ici à Montréal pour travailler à McGill, j'étais la seule astrophysicienne. J'étais très heureuse de venir à McGill, mon alma mater, mais j'avais peur d'être toute seule dans mes recherches. Et je rappelle très bien que mes collègues à l'Université de Montréal m'ont fait une grande bienvenue pour moi. J'ai téléphoné à René, est-ce que je peux venir et visiter parfois? Et ils ont dit, bien sûr, viens. Maintenant, oui, c'est vrai, McGill a supporté ses recherches et je pense que avec l'Université de Montréal, nous sommes peut-être le plus grand au Canada, peut-être?
I think so. Yeah, together I think we're the biggest group.
Yeah, in Canada, so I think it's been quite a good partnership over these years.
Yeah, absolutely. To continue on that, so you're both from two universities that I cherish very much and two different departments that have a lot of close ties together. So can you talk about the strength of this collaboration between the universities, between the departments, and how does this type of collaboration help us answer the deep and complex cosmic questions that we're asking ourselves?
Well, when we started to develop the astrophysics faculty at McGill, and I was the only person there, you need a committee to have to make these kinds of decisions. We invited people from University of Montreal to help us out and to make decisions, which was a fantastic way to get to know each other. And then we joined the Centre de Recherche Astrophysique de Québec, CRAC, from... Yes, that is what it's called. We're all on crack. We work together. We have annual meetings that are very, very productive. And I have to say that one of the goals of the interdisciplinary nature of the Trottier Space Institute was to take advantage of the fact that there's research going on in exoplanets in multiple departments that didn't necessarily know about each other. And that, knowing that there's such a strong group at University of Montreal, made a good argument for creating this interdisciplinary center. And I think there's tremendous collaborations on exoplanet research. We have fantastic researchers at McGill like Professor Andrew Cumming and Professor Eve Lee and Nick Cowan, who participate very heavily in IREX activities.
Yeah, I just to jump on this, when we created IREX back in 2014, you were just about to start an Exoplanet group, and I was made aware of that. I said, well, okay, well, let's team up. And this is how we got to get McGill, and later on we got Bishop. James and Rose here. Bishop is now involved, and through our insemination work, we also have Laval. So it's this teamwork, this collaboration is absolutely fundamental to what we do. This is local, and of course, we have this collaboration goes beyond.
And we can also mention the Planetarium of Montreal as well, who now has a research program, and we have a researcher there who's an associate professor at the Université de Montréal. Yeah, fantastic. Donc, pour élaborer sur cette question de collaboration, c'est quoi l'importance à l'international et même au-delà du monde académique? Quel rôle joue l'industrie, le gouvernement, la philanthropie bien sûr, la société entière dans notre quête de mieux comprendre l'univers?
Bah, écoute, je vais prendre le télescope James Webb, qui est un très bel exemple de cette synergie.
Des belles chaussettes en passant.
Oui, c'est pour les
J'ai les mêmes.
Donc, oui, donc la collaboration est absolument essentielle pour un projet de cette envergure-là entre la NASA, l'Agence spatiale canadienne et l'Agence spatiale européenne. Et au Canada, il a vraiment fallu prendre tout ce qu'on avait de meilleur pour faire ça. Et en particulier, l'industrie. Oui, nous, scientifiques, avons les idées de grandeur de faire des choses. Et on peut guider les instruments à développer, mais au final, c'est les ingénieurs qui le font. Et on a une excellente industrie aérospatiale au Canada. Donc, l'instrument a été mené par Honeywell à Ottawa, mais avec plein de partenaires partout au Canada. Et bien sûr, ça prenait aussi l'Agence spatiale canadienne et tous les partenaires comme le Conseil national de recherche du Canada. Donc, encore une fois, il a fallu prendre tout ce qu'on avait de meilleur pour faire ça. Et je pense que ce n'est pas spécifique au projet James Webb. Tous les grands projets d'envergure ont une collaboration internationale.
I guess I'll just add a few words. You spoke, very wisely about the role of industry, and philanthropy is also huge. I mean, I think today we're celebrating tremendous philanthropic gifts, and of course, government funding, it goes without saying, is the bedrock. But I had the privilege of being the chair of an advisory board for the Harvard Astronomy Department recently, and I was really struck by how much philanthropy plays a role, particularly at institutes of that nature in the United States, and where it's almost greater than their peer-reviewed funding, which was really fascinating to me to learn. And sometimes when I go and give talks south of the border, I'll make a joke and say, here in Canada we don't have those kind of resources, so we have to be smart. And of course, I'm just kidding when I say that, but the tremendous philanthropy that we've received from, that both of us have received from the Trottier Family Foundation raises us quite a notch to a level where we can compete with the top institutions around the world. And not only that, we can then attract even more resources. I mentioned in my speech. We've been able to attract funds from the Simons Foundation, from the Gordon Betty Moore Foundation, and beyond, and that's been extremely important to our institute.
Yeah,
So,
if I may add on this, the James Webb Space Telescope was a technical challenge, but then soon I realized that okay, we're going to have an incredible scientific opportunity, but we don't have enough resources. And that was the main motivation to actually go for philanthropy, and Lauren really understood that. And God, it made a difference, a big difference, and will continue to make a big difference.
Yeah. And this is one of the reasons why this renewal and this new donation comes at such a crucial time, because we have this onslaught of data that's coming in now, and if our operations were to stop now, then all the effort put into the instrumentation would have been for naught. So it's a really fantastic time to be getting this.
Absolutely.
Yeah. So you're now, of course, from your very large CVs, you're now both very established researchers, world leaders in your respective fields, many awards between the two of you. But it didn't start from there. It started from maybe a young age, maybe a specific experience. So where did your curiosity and your spark and your thirst for knowledge to understand the mysteries of the universe come from?
Well,
We're getting personal here.
neither of my parents is a scientist, was a scientist, so I can't really say. I mean, I think they were curious, interesting people, but they weren't into science. I really liked Star Trek as a kid. I don't know if that played a role. I think I don't know. I think that it's part of our nature, part of who we are. I know, sometimes I think, well, I'm Jewish, and I think that, we have a tradition of arguing, discussing, thinking. But on the other hand, at the Trottier Space Institute at UREX, we have people from all sorts of different backgrounds, cultures, who all share that same kind of passion. So I don't know exactly where it comes from. I don't know, maybe René has a better answer.
It's pretty much the same answer. My parents are not scientists, but I knew very young, when I was a teenager, that physics would be my thing. And it's only later that I realized that, God, I was privileged to know that. So, I just find my way to do astronomy. I was just explaining to my doyen here, Frédéric, that what really sparked my interest in astrophysics was, in fact, a philosopher at CEGEP, not a physicist. So, yeah.
You're just saying that because he's a philosopher.
No, that's true. It is true. But one thing to say is that, I come from a small city called Thetford. It used to be called Thetford Mines. They removed the mines. At that time, I had good marks, but not more. And I didn't feel I could, be what I am today. And so, I never anticipated I would be here today.
I'll just say I always loved, puzzles. I still like puzzles. Any kind of puzzle, you give me a puzzle, I'll do it. I sort of feel that's what we're paid to do.
I hate puzzles. I find them too challenging.
All right, never mind that.
Je pense que peut-être une des conclusions, c'est qu'il y a plusieurs parcours qui peuvent mener à la science. Donc, il n'y a pas seulement un profil qui fait de quelqu'un un bon scientifique. Plusieurs parcours, plusieurs backgrounds, plusieurs types de bagages qui peuvent mener à une curiosité intellectuelle. Donc, bien sûr, les dons annoncés aujourd'hui sont transformationnels pour nos instituts, pour nos universités. Mais en quoi sont-ils aussi significatifs pour la société en général, pour la communauté? Et plusieurs posent souvent la question, pourquoi est-ce qu'on met tellement de sous, de ressources dans une science qui regarde vers l'extérieur, vers l'espace, lorsqu'on a des problèmes ici sur la Terre? Alors, c'est quoi les bénéfices de l'astronomie et de l'astrophysique pour l'humanité au complet?
Écoute, je dirais que la science fondamentale, c'est vraiment les piliers de notre civilisation. Et on prend souvent trop pour acquis les technologies qu'on a, vos téléphones cellulaires et tout ça. Mais tout ça a une racine. Et en fait, je dirais que la racine la plus profonde de l'innovation, c'est la curiosité. C'est ce qui est la racine de la science, des arts et de la culture. Et donc, j'ai l'impression qu'on ne peut pas se permettre de ne pas être curieux. Donc, on peut donner des exemples évidemment, on est animé à répondre à des grandes questions, comme y a-t-il la vie ailleurs, c'est quoi l'origine de l'univers? Et pour répondre à ces questions-là, il faut développer des nouvelles technologies, il faut vraiment aller pousser nos technologies à leurs limites, qui, tôt ou tard, finissent par donner des applications qui servent le bien commun. Si vous pouvez prendre des selfies, là, dites merci aux astronomes, parce que ce sont les astronomes qui l'ont développé, cette technologie-là. Si vous pouvez texter, parce qu'il y a un Wi-Fi ici, ce sont les radio-astronomes qui l'ont inventé. Donc, il y a plein d'applications comme ça qui finissent par servir la société. Donc, je pense qu'on ne peut pas se permettre d'être curieux. Le jour où l'être humain arrête d'être curieux, je pense qu'on laisse la planète aux rats et aux coquerelles.
Oui, je peux ajouter que nous savons que si nous avons une lecture publique et nous ajoutons les mots « trou noir » dans le titre, que nous aurons un milliard de personnes qui veulent venir et qui sont intéressées, curieux. Et beaucoup d'entre eux sont des jeunes. Et je pense que l'astronomie et la cosmologie attirent l'intérêt scientifique des jeunes qui veulent comprendre l'univers, mais peut-être qui vont aller dans une direction différente. Mais it's a hook that brings them into science and scientific thought, and then can launch them in many, many different directions. So I think astronomy cosmology is a very useful tool for engaging the public in scientific discourse.
And we know that astronomy and space in general holds a special place in people's imagination. It's one of the most unifying sciences in a time where science is quite polarized. We could see it during the COVID pandemic, but in general, people are very open to astrophysics and space sciences. It's what we call the gateway science, really, and so it's a fantastic tool for that. So for the last 60 years, many have said that we've been living in a golden age of space exploration, and many of the high-profile space research has involved sending astronauts and unmanned probes to faraway places, sometimes on dangerous missions. But with the introduction of new and more powerful telescopes in space, but also on the ground, what will be the role of these observatories? How will they complement these space exploration missions done by humans and with rovers? And how will they play a future in the way that we unlock the deep mysteries of our universe? So maybe talk about some of the telescopes that we are building on the ground and how they will be complementing what we do in space.
Well, I'll just start out by saying it is truly a golden age, and it sounds like a cliche, but as I say to my students in our introductory astronomy course at McGill, that's for anybody to take, for art students, for anyone to take, that of all the sciences, astronomy is the only one, I think, that where the introductory textbooks are still being rewritten or still being changed. Astronomy 101 books, the story is still being written. And so you have revolutionary science happening on the ground. Here in Canada, we're leading efforts in radio astronomy, which has undergone a huge revolution thanks to the computer gaming community that has developed ever faster electronics that we can then harness to solve mysteries like the nature of dark energy or fast radio bursts, things like that. But on top of it, you think of the world of gravitational waves. Gravitational waves were not discovered before 2017, and that is opening a whole new window on a dark universe. People are now detecting double black hole mergers, something that you cannot, even in principle, detect through any form of light. That is a whole revolution in how we're seeing the universe, and that's fully ground-based, although there are ideas for eventually making it space-based.
Double black hole, that means twice as many people want to come to the talk.
Right, absolutely.
Not much to add. It's now obvious. In my time when I was an undergrad, astronomy was very much optical astronomy. There was a little of UV, radio, but now astronomy is at all wavelength, and we need that information to unveil the universe. And I insist, small and big. We need also a small telescope. Recently, we made a discovery of a potential water world. It was first discovered by a small satellite test by NASA. And the planet was confirmed with observation of the Mont Magnetic Observatory. Then we used another facility on Telescope Canada Francois with an instrument that we built with colleagues in Europe to confirm, measure its mass. And now we're writing a proposal to actually confirm that it's got an atmosphere of water with James Webb. So all of these facilities are working hand in hand, and so we need them all, from the biggest to the small one.
And I would just add, telescopes like CHIME, which is built, it has had a huge impact, but built on a small telescope kind of budget. It dovetails so nicely with another kind of revolution, the same computing revolution that's been enabling massive leaps forward in radio astronomy is also giving us a huge new view of the time domain universe and seeing the transient sky. How many transients there are out there? We think of astronomy, you always see the sun, it's always there, but there's all sorts of objects in the universe that just pop in, explode, and then vanish. And what are they? We're just learning this, and from across the electromagnetic spectrum, from optical, from X-ray, gamma ray, all the way to optical, infrared radio waves, and now gravitational waves. It's a whole new ballgame.
On en a déjà un peu parlé, mais chacun de vos instituts mener un fort mandat éducatif et de vulgarisation scientifique. Et ça, c'est dès le début, dès vraiment l'inauguration de vos instituts, en plus de votre vocation de recherche. Alors, quelle est l'importance de ce volet, d'après vous? Et c'est quoi votre message pour les jeunes astronomes en herbe que vous rencontrez lors de vos conférences publiques, par exemple, pour les encourager à continuer leur curiosité et leur exploration?
Je ne pourrais pas m'imaginer faire ce que je fais sans aussi le partager avec le grand public. Je pense que l'astronomie, c'est l'une des sciences qui est la plus accessible à tout le monde. Et il n'y a pas juste moi qui se pose la question s'il y a de la vie ailleurs. Personne ne reste indifférent à voir un ciel étoilé. Et donc, je pense que c'est notre devoir, nous, scientifiques, là, de sortir de notre tour d'ivoire puis d'aller parler au public pour l'expliquer les mystères de l'univers. Et c'est possible de leur expliquer. Là. C'est à la portée de tout le monde. Et j'inclus là-dedans les petits-enfants de 5 ans. Donc, et le message que je veux leur donner, c'est que je les invite d'oser rêver, comme moi j'ai rêvé au début dans ma carrière, et aussi de leur faire rendre compte que leurs capacités sont probablement plus grandes que ce qu'ils le pensent. Et donc, en fait, leur seule limite, c'est leur volonté et leur détermination.
Je peux ajouter seulement que les événements astrophysiques attirent tellement de personnes, et je pense de l'éclipse partielle qu'on avait il y a quelques années, et que nous avions 10 000 de personnes sur le campus ici à McGill et aussi à l'Université de Montréal. Et je veux avertir qu'il y en aura une éclipse totale.
Le 8 avril.
Oui, et nous pensons en 2024. Et nous pensons déjà comment est-ce qu'on peut utiliser ça, encore une fois, pour promouvoir la science.
But people in Laval, go downtown because you're going to miss it.
C'est vrai, donc la bande de totalité va traverser l'île de Montréal, donc il y aura une sélection qui va se faire.
Elle sera en plein sur le mont Mégantic.
Did you have anything else? Oh, you started saying something.
I did.
Okay, all right. Donc, mettez-le à votre calendrier, le 8 avril 2024, pour l'éclipse solaire totale au Québec et à Montréal. So to end this portion here, I wanted to we're all about looking towards the sky, looking forward. So on a time scale of about 10 years, what is the scientific question that you are the most fascinated by? What's the next great adventure for you and your team?
Well, I have to say that what the work that René and all of the exoplanet people are doing with JWST, I think it's fantastic, fascinating. I can't wait to find out, are you going to see biosignatures? Is there life out? That is just so exciting. I'm also very excited by a lot of the other research happening at the McGill Space Institute. We have researchers working on Event Horizon telescopes, studying Event Horizon, the black holes. We have researchers studying the epoch of reionization, that is the very early universe formation of galaxies not long after the Big Bang. Obviously, there's so many other things going on. The nature of neutron star interiors, and of course, I can't help but mention, because it's what fascinates me, is these fast radio bursts, these crazy short bursts of radio waves that last only a few milliseconds, that are coming from cosmological distances far outside our Milky Way galaxy. We don't know what they are, and I would love to be able to figure that out. And if we never figure them out, if we never understand them, we'll also be able to use them as novel probes of the cosmos. So that's something I look forward to.
I'll always remember, this is something you say before some of your talks about fast radio bursts. At the start, you say, I'm going to talk about fast radio bursts for 60 minutes, and at the end, you too will not know what fast radio bursts are, because they're just that much of a mystery. So yeah, go ahead.
Yeah, well, this is a long list of things which I also subscribe to. These are very excited. I mean, out of my field, when I saw this first picture of a black hole, it's just, wow, really? We got a picture of a black hole? We see the shadow, and it was. I was feeling where I was in the movie Interstellar. But coming back to my field, I have modest expectation about finding life in the next decade. That nature would be very generous if we have that, I think. But more concretely, I mean, there's about a handful of exoplanet systems for now that are known to be potential habitable worlds. So we know where they are. You can point them. They're here. And so we will observe them, and we have data already. So Answering the question whether they have an atmosphere, that would be just an incredible discovery, and especially if they have water in it, that would be a big, big deal. And that could well happen in this decade. So, but we're not taking any chance. We're also working on a different front, the development of giant telescope, the extremely large telescope in particular, which are going to be ahead of the TMT. We're working on the development of an instrument called ANDES, which is basically a high-resolution spectrograph that we know will have the capability of detecting these biosignatures. So if these things exist, this telescope and this instrument should be able to do it. And that's about a decade away where we can have these first observations. So yeah, the next decade will be pretty busy.
Yeah, lots to look forward to. Alors, à ce moment, on va prendre des questions du public. Si, entre deux bouchées de tartelettes, si je peux bien voir. Donc, est-ce qu'il y aurait des questions? C'est toujours la première la plus difficile.
It all starts like this, and I always say there's no stupid questions.
Il y a une main là-bas.
So if people want to follow what's happening at IREX and TSI, and they're in Montreal, how can they do that?
Well, at IREX we have a newsletter. You can subscribe to it, actually. We have a website. We're just about to release a beautiful website that Nathalie developed and her team. So that's pretty much the way you can connect with us. Am I missing anything, Nathalie?
Follow us on social media. We're on Facebook, Twitter, LinkedIn. We're hoping to recruit a teenager to help us with TikTok. No. We're exploring other media as well, but you can find us on most social media platforms.
Yeah, same for the Trottier Space Institute. We have a website that's regularly maintained, and we have some fantastic social media. I know that I'm just looking. I see. I'm going to call you out. It's Hannah Fronenberg, who's been is a PhD student, has been working very hard on it, and Carolina Cruz-Venazia, who's our program administrator, and many others here have put tremendous amounts of effort into social media, and it's been paying off greatly. And anybody is obviously very welcome to like us on many of the different platforms.
D'autres questions? La tartelette est trop bonne, hein? On est en train de la manquer, nous autres.
So, a question. If the ground telescopes are becoming so powerful now, we can see so far out, does this mean that manned space travel, like people like my generation grew up being fascinated with, is that going to become irrelevant and unnecessary to research?
I don't think so. We'll always be fascinated by trying to go to the moon and Mars. But I would say that, those ventures are very, very expensive. And for the same amount of money, you can do a lot by space exploration, robotic exploration. So, that's what I favor personally. But I don't think we're going to stop dreaming to go beyond our Earth and the Moon.
Yeah, I think I agree 100% that we're two astrophysicists, so of course we see things through telescopes and think that's wonderful. But when you see some of the Apollo missions and what's planned and the ideas of going beyond, and I loved The Martian. How cool is that? I don't think that we'll ever be inhibited from those kind of aspirations.
When you think about Canada being involved in the upcoming Artemis missions, how do you feel about that?
Well, I'm excited that we're part of it. I mean, it is something that it's being done, and that would be sad if we were not part of it. It's kind of cool that, after 50 years more that we're coming back to the moon. It just shows how wild this was, 50 years ago.
So for context, the Artemis missions are, we just had a launch last week, Artemis 1, so we're going back to the moon, and Artemis 2 will be a mission that orbits the moon, doesn't land, but a Canadian astronaut who has yet to be named will be participating, and then Artemis 3 will be landing on the moon and staying there, with the hopes of having a more permanent presence on the moon and maybe using it as a base to go to Mars later on. D'autres questions? Est-ce qu'on peut apporter un microphone là-bas? Merci.
Since you said that there's no stupid question, I'll go ahead and ask this question. Is there a relationship between, or how can what you do help us understand global warming and climate change? Is there a link?
Well, actually, yeah, this is one of the aspects of exoplanet research that we're learning a lot about the diversity of exoplanet system, and in some way it helps understand, put into context our own system. So it is very useful from that perspective. We're basically doing exoclimatology. It's a subject on its own, doing numerical simulations, trying to match the observations. So yeah, in general, it's try to put in context our own climate.
Yeah, I mean, just to amplify that, it's very, people have very sophisticated climate models based on this one lone planet. And to suddenly have thousands of exoplanets where you can, have new ways of calibrating these kinds of models, I think that has tremendous potential for helping us to understand things back home.
Le type de science que font les personnes qui travaillent en exoplanète, en astrophysique et les personnes en sciences du climat, c'est très complémentaire, très, très similaire. Et en fait, il y a un article qui vient de sortir sur UDM Nouvelles aujourd'hui qui parle du parcours de certains étudiants qui sont passés par l'IREX. Donc, on parle d'une étudiante, Myriam Rassau-Aymon, qui vient de finir sa maîtrise à l'IREX seulement plus tôt cette année, et elle a commencé un doctorat en climatologie dans une université à Londres. Donc, il y a beaucoup de recoupement entre les deux et il y a beaucoup de complémentarité entre les deux domaines de sciences, certainement.